All right, so in this video, I'm going to look at another piecewise example. And so if you had this function, f of x equals x squared plus 2 if x is greater than 1, f of x, which remember is y, will equal 2 if x is between -3 and 0, including the 0, and f of x equals x plus 4 if x is less than or equal to -3. So remember from last time that these are the conditions you need to consider before you decide which rule to use, okay? So I might ask you to do something like find f of -5. I'm gonna go ahead and put a bunch of them on here. You go ahead and start figuring out what you think the value should be for these. F of -3, f of -1, f of 0, maybe f of 1/2, 1 or 2. Okay, let's go ahead and find all of those. So remember, these in here are your x's, and your job is to find the y value associated with that, or the output of the function associated with that. F of x, this right here, that's really y. Okay, so what you need to do, you're not going to plug -5 into all three rules. You're going to determine which rule you should follow. So -5 is less than -3. It's further to the left. Like, you got to think about, sometimes that can be tricky to people. Okay. All right. So -5 is further to the left than -3. So that means that -5 is smaller than -3 is less than it. So I need to use the bottom rule. So that means where the x is, I'm going to put a -5 and then add 4. Okay. To find f of -3, there's a -3 on both of those conditions. But you see how only the bottom one has the or equal to on it? So that again means I need to use x plus 4 when I calculate that. So I'm going to put in the -3, add 4, and this time I get a +1. Okay. Right now I'm going to be using an x of -1. Okay, so -1 is not less than -3. -1 is to the right. So I can't use the bottom rule. -1 is between -3 and 0. So that means I use the middle rule. Now look at that. The middle rule says your output is 2. It doesn't say 2 plus x or 2 times x. It says your output is always 2. So if x is -1, the y will be 2. I don't plug in my input, I just get 2. Okay. 0 has an or equal to on it. So that means I use the middle rule for that one also. So the output will be 2. Now, when I think about 1/2, 1/2 is bigger than 0. So it's right there to the right of 0. But it's not bigger than 1. Okay. So I can't use the middle rule because 1/2 is bigger than 0, but I can't use the top rule because 1/2 is not bigger than 1. No rule tells me what to do. That value right there is undefined. Okay. All right, now I'm going to be asked to do f of 1. The input is 1. Okay, so I have to decide what to do for that. So again, I look up here and I think I'm going to use the top rule, but when I look more closely, I see there's no or equal to on that. Okay, so once again, I have something that is undefined. They literally did not tell me what to use when I work out f of 1. Now for f of 2, I would use the top rule because 2 is bigger than 1. So I would put the 2 in for the x and square it and then add 2. So that would be 4 plus 2, which is 6. All right, so that's just evaluating the function, deciding what rule to use. That's kind of the main thing I want you to do. But piecewise functions are very important. They are used a lot in real life scenarios. It's very rare that one function fully describes a situation. A lot of times we need pieces like this. And we'll talk about some of those applications later. All right, now one more thing I want to do is graph this. You don't always do everything. You don't always find values and graph. I just want to try to help you make sense of what this piecewise function is saying. All right, so I'm going to be looking at these conditions over here, and I'm going to be thinking about what happens in the various areas of the coordinate plane. So let me just put some tick marks on this graph, and then I'll be right back with you. Okay. Oops. Okay. All right, and this is my X, this is my Y, and I'm now looking at those conditions. So I do one thing when I'm to the right, when my X's are bigger than 1, which means when I'm to the right of 1 on the X-axis. This dashed line is not an asymptote, if you know about those. This is just me trying to cut up my coordinate plane to get an idea of what I should do where. So when I'm over here in this area, I should use y equals x squared plus 2. Okay. Then I've got a rule that's supposed to be used when I'm between 0 and -3. So here's an x of 0. Here's an x of -3. Sort of. And when I'm in between there, that's when I'm supposed to use the rule y equals 2. Okay. And then when I'm less than or equal to -3, that's when I'm supposed to use the rule y equals x plus 4. So that kind of gives me the idea of what should be going on. And y equals x plus 4 is a line. So is y equal 2, but it's a horizontal line. And then y equals x squared is a parabola. So I kind of have that in the back of my mind. And now I'm going to put some points on my graph to try to be able to sketch what should be happening. Okay, so I'm going to do the easiest one first for me, which is y equal 2. Y equal 2 is just a horizontal line up at 2. And I use that when I'm between 0 and -3. So I'm going to be up here when I'm between 0 and -3. Now look, y equal 2 does this. I'm just only using it when I'm between 0 and -3. Now you got to watch out about the ends of that particular piece that I just graphed. The -3 side does not have an or equal to. So that means I'm going to use an open circle on that side. The 0 has an or equal to. So I'm going to use a closed circle over there. So I'm really making very clear to people that when they're at an x of 0, the value of this function is going to be 2. You should use that rule. Okay. All right, so now let me go ahead and use blue for this one. All right, now, that is when I'm to the right of 1. So that was actually the only thing I had was f of 2. So, I knew that when I plugged in a 2, I got 6. Okay. I might want a little more information than that. 1, 2, 3, 4, 5, 6. Okay. So I know that point's on it. And I really want to know what happens when I plug a 1 into that rule. Turns out to be 1 squared, which is 1 plus 2, which would give me 3. And I want to know that because I want to think about how to sketch my graph. Okay. So the parabola would go in and be a U shape, right? And if I continued, if I put an x of 0, I'd be at 2. So this parabola is going to come in. And if I had continued it, it would go there and then it would flip around and, continue on up. It's just I'm only using it when I'm right. When I'm right over here. Let me clean that up a little bit. Okay. So I'm only using it when I'm on this area of the coordinate plane. I don't use it when I'm over here. Okay. Even though that it would be a U if I continued it. All right. And then at the end, right there at an x of 1, there is not an or equal to. So that means at that end, I need to tell somebody that they should have an open circle there. It should be right there at 1, 3, but an open circle. So like if you're at 1.0001, you would find the value right just a smidgen up from 3. Okay. Now let's do the next one in green. So that's the line y equals x plus 4. Okay. So see that was this area right in here. See, when x was equal to a -3, we found some values there. When x was equal to -3, we wound up getting 1. When it was -5, we got -1. So -3, we got 1. -5, we got -1. And we know that's a line, so we're ready to just connect that. Remember, that line would have kept going. It's just we're not using it in that area of the coordinate plane. We're just using it in this region over here. Okay. Now, when we get to that boundary where that -3 happens, there was an or equal to on that, so I should put a bold dot there to tell somebody that f of -3 is 1. It's not 2. F of -3 is 1. All right, now one more thing we'll do. Before I do that, one big idea. Do you notice how this has 3 pieces, but it's really just one function called f? F is all 3 pieces snipped and assembled in this way, okay? All right, now let's go ahead and do domain, and then we'll do range. Okay? So for the domain, I want the x's of all of these points. So you should be thinking that you need to smash to the x-axis, but you need to smash all the pieces to the x-axis, okay, and see what's covered up. So everything, this keeps going up and out. So everything over here, there's going to be x's that I can plug in from there. But when I get here to 1, you see how there's an open circle there? There's no ordered pair with an x of 1, so that's a gap. That's a hole. Then nothing happens between 0 and 1, but then at 0, that point 0.02 happens, so that's going to be part of it. And then if I smash to the x-axis, all of those would be covered up. And then I know there's a gap vertically here, but you see how the green piece has a closed circle? Like when x was -3, there was an ordered pair, -3, 1. So you're going to go right through that and keep on going. Your domain is actually going to be from -infinity all the way to 0. Don't stop at that -3, because even though this happened, -3 was a possible value. All right, so go all the way to the 0, put a bracket because you have a closed circle there. Then I'm going to jump over that gap and pick back up at 1 and then keep going. But there's an open circle on 1, so I'm going to put a parenthesis on that. And then you would connect it with a U. The domain is basically those conditions from up here, just consolidated, okay? Since there was an or equal to, I could run all the way from -infinity to 0, but then there was a gap between the 0 and the 1, okay? Now range, you really can't do range of a piecewise very well unless you get the thing graphed so you can look at it. So that's a lot of times why we have to graph. Okay, and for range, domain was x's, range is the y's. So you should be thinking from bottom to top. So I can see that this keeps going to negative, keeps going to the left, but also down. So if I smashed everything to the y-axis, I would have everything covered up from here, okay, all the way to the 1 for this green one, and it would be a closed-in dot. Then I jump up here to 2. All of these points would have a y of 2. Then I have to jump again to get to here, which would have an open circle since there's no point there, and then everything on up. So the range would be -infinity until I get to 1 with a bracket. Okay, remember, think y coordinates here. Then I'm going to union that with just the number 2. So I'm going to use the set consisting of just 2, then union that with the interval from 3 to infinity. And I put a parenthesis because that had an open circle on it. Okay, so that would be the domain and the range of that piecewise function. Okay. All right, so in the next video, I'm going to go and look at some of the homework questions and kind of do a few of those that are in the homework. And then we'll focus on an application of piecewise functions in yet another video. The only reason I do a bunch of videos is I think for some of you, it's easier to load a short video than it is to load a long one. So let me stop sharing.